Problem number 7 says, write the equation of the line. Okay, well, we've done this before. Right? How do we start?
Slope.
Slope. And how do we find slope, Bryce? Do you remember?
Y.
So 6 minus 4.
Oh.
And 1 minus 2.
Yeah.
So y minus y, x minus x, and pay attention to how my fingers are moving here. 6 minus 4, and then 1 minus 2. See how I'm going the same direction? Have to. So my slope is 2 over negative 1 or negative 2. Now what do I do, Bryce?
You throw that in as a slope. You gotta find B.
Okay, so you're going to do it using this format. Remember, we have a couple different formats, and nobody cares which format you use. So if this is what Bryce likes, this is what Bryce is going to do. And he's going to pick a point, doesn't matter which one, and he's going to have an x and a y from that point, and he's going to plug it in along with his slope. So his y is 4, his m is negative 2, his x is 2, must be what?
Does it have to be the first?
No, you can use either point. Now, but Bryce, listen, if you use this x, then you have to use this y. If you use this x, you have to use this y. So you have to stick in the same point, but it doesn't matter which point you use.
Okay.
So 4 equals negative 4 plus b, and what does b equal? B's don't cancel. You're adding this one over here, and it's going to be 8. So your answer is y equals negative 2x plus 8. Okay? Did anybody look at, actually there was a part B on that question. Should we do B?
I didn't do that.
Okay, let's do B. B says the same thing. Write the equation of the line, but now it's parallel to this one, and it's containing this point. All right, so what's our strategy here? It's a little different problem. What's our strategy? Anybody have a thought on that? What'd you say?
First, you have to put the first equation in line with the next.
Exactly. Because, Olivia, you're exactly right. When I start rearranging this equation, and I'm going to subtract the 6x from both sides, and then I'll divide by negative 3, this is going to give me the slope of the line, isn't it?
Yes.
To find the slope, we get y by itself. So we just take our equation and we rearrange things so y is by itself. Now, what's the slope of this line? 2. Now, you got to read your question. It says parallel. What does that mean? Parallel. Same slope. So I'm going to use 2. I'm going to use 2 because it's parallel. If it had said perpendicular, then I would use negative 1/2. Right? But it didn't say that, so I'm using 2. Now I'm going to use this point, and I'm going to use this slope. And this time, I'm going to use point-slope form. Remember, you got a choice. Over here, we use the slope-intercept form, which is fine, doesn't matter. But for those of you that like to practice the other way, I'll do the point-slope form. And again, it's just a matter of plugging in. This is x1, y1 now. So y plus 3, because it's minus a negative, equals 2x minus 2. So y plus 3 equals 2x minus 4, subtract 3, y equals 2x minus 7. Bryce, you okay with that now? Olivia?
Yeah.
On our test, is there gonna be questions like you have to use like a certain formula?
Nope. Olivia, I want to say it one more time for everybody. The test looks exactly like practice test 2 and practice test 3. They're identical. That's what the test looks like. The directions are the same.
Is it like the same order and everything?
Everything's the same. There are no surprises. If you know how to do the problems, you are going to do great. Right? It's been a challenging week for sure, but you know what? We gotta regroup. We're gonna study this weekend, we're gonna practice, and we're gonna get this.
Is it Monday review day?
No, Monday we have no school.
Oh. Forgot about that.
Okay, anybody else have something on practice test 2? Will?
C on number 8.
8?
Like I did it, but I don't know what C is.
Okay, I did that yesterday.
On A.
Uh-huh, I did. When is the ball on the ground? So I'm not gonna redo the whole problem, because I did it
If you did
yesterday.
it yesterday, so did you.
But I will, let's see, my equation, I need my equation to do the problem, so I have to go back up and get that. So the equation is h equals negative 16t squared plus 80t plus 20. That's the equation I'm going to use to solve all of these problems on this page. When is the ball on the ground? Remember, there are two variables. Excuse me, two variables. What does this stand for? Height. What does this stand for? Time. When the question says, when is the ball on the ground, I have to plug in something for either H or T. They didn't really give me a number in this problem. I kind of have to use my own smarts. If the ball is on the ground, Gibran, okay, I'm asking.
0 height.
0 height, you're exactly right. If the ball is on the ground, then its height is 0.
0.
Okay? So then we'll use your quadratic formula or something and solve that equation.
Okay.
All right, anything else on practice test 2? Ethan Topham?
Number 6.
6. Write the equation of the circle whose center is 2, -1, and whose radius is 5. Now, this is one of those problems where if you know what you're doing, you don't even need to show any work. How do we write the equation of a circle? What does that even look like? Remember, it's something squared plus something squared equals something. Remember, that's the equation of a circle. First parentheses is going to be x minus 2 and y plus 1 equal to, not 5 squared, so equals 25. This is always r squared. So if we had, there's really no work to show. That's it. That's all there is to it. If we had a center of -3, -4, and a radius of 6, that circle would be what? X plus 3 squared, don't forget to square it, plus y plus 4 squared equals 36. The back backwards of that is, if I gave you the equation of a circle, and I said, what's the center? You would look at this and say, okay, the center is 2, -5. And then I said, what's the radius? The square root of 18, which you would reduce to 3 root 2. Remember, this number is always r squared. You have x squared, y squared, r squared. Anything else on practice 2? All right, then let's get out practice test 3. And oh my gosh, when you look at it, you'll say, this is 4, and it looks just like number 2. And I will say, yep, it does. And that looks just like your test. So we're looking at practice test 3. Alrighty. Now, practice test 3. Let's look at the ones that we had a question about today. So let's start with number 6. Can you write the equation for number 6?
X plus 4, x plus 3.
X plus 4 squared plus y plus 3 squared equals 6. That's it. How did we get 6? This is number 6. How did we get equal 6? Ron, you paying attention?
No, I have a question.
You're good now? Okay. Veronica, do you know how we got this 6 right here? We're on question number 6. Practice test 3.
Mrs. Ford, sorry, when did you hand this out?
They all got handed out at the same time.
Hey, you might have been gone that day.
No, not if she has practice test P. She has practice test 3 because they were handed out the same day.
You handed me this yesterday. Pass on this. No, it's right here. She has it right. That's 2. That's 2.
Right here.
Oh, they were sitting together, sorry.
Veronica, do you know why that's a 6? It's the radius squared. And when I square the square root of 6, I just get 6. All right? Now I want to go ahead and do 7 too, because Bryce had a question about that. So would there be someone who would want to come up and do 7A and 7B on the board? I'm happy to do it if you don't feel up to it. But if there's Maya, will do, you do an A or B, Maya.
I can do
All right, Maya's going to do 7A. Do you want to do 7B?
Sure.
Okay, do it side. You can erase this, but do it side by side here, so we're on this board.
Why don't you do the 3 and 2 on this one? What's the difference?
No, when you write your equation, you square this. The radius squared. So I'm not breaking that radical down. I'm squaring it.
What's the equation, just so I can write it down so I can remember?
It's, I mean, this is what it is. I mean, that's all. I don't know what else to say. It would be x, minus, you're subtracting. Now that turned into a plus because you subtracted a negative. So it's squared. And then y minus y squared equals r squared. Okay, now, again, if you are up to it, let's have you be working on these two problems right now, problem 6, or I mean 7, 7A and 7B, writing equations of lines.
Oh, is it this?
Or, you know, way down. What's 3 over 9?
I have to calculate up to.
That would make a difference. Keep going. Okay, Maya's done.
Sorry, no. Oh, wait.
So you might want to check out Maya, see if you agree with her, disagree with her. She did slope intercept form. You might not do that same form, but you should get that same answer.
I don't think mine is on.
Will, are you saying you disagree with her?
I just got Y equals 2x minus 1.
How'd you get 9?
I had, I don't know, my math, she can write, I don't know. I just got 9.
Oh, you're.
Oh,
Whose is the top? That one is 4. Do we have to know what's that? We already did why is that? That was 6.
how did you, that's a 2.
Yeah.
So why is that a 3?
That's your question.
Yeah. Are we supposed to be in the same place?
Depending on who's slope.
What's your slope?
Okay, you guys got it?
Maybe she did.
What's the matter, Abby?
We don't have the same answer.
You and I don't.
Abby, it's supposed to be negative 1/3. No, it's not. It's opposite reciprocal.
I might have a mistake on my,
It's supposed to be negative 3. It's the opposite reciprocal. Perpendicular.
okay. What point are you using?
Abby, you added 1. So subtract.
Okay, why does this say x plus 1?
Did you get the same answer?
Okay, now Abby's done, so let's take a look at these and figure out what we're doing. All right, how are we doing here? Anybody have a question about either one of these, writing equations of lines?
Are they just 2 separate parts or are they supposed to like?
These two answers? No, they're two separate problems. They just both have the same directions, writing the equation of lines. Okay, now I've had a request to do which problem? Right. Problem number 1 is probably the properties, right?
Yep.
Okay, so here we go. We're all looking at problem number 1 on practice test 3.
Distributed.
And A would represent which property?
Distributed.
Is it distributed? What about B? Who said it? Commutative. B is commutative. Why is B commutative? And it's of addition, by the way. We're going to say commutative of addition. And why is that? It changes the order change. So if you look at the left side, it's 5, then X, then Y. If you look at the right side, it's X, then Y, then 5. The order changed. Whenever the order changes, it's commutative. This is commutative of addition because it's an add problem, right? Okay, what about C? Additive identity. Additive identity. Now, I don't know which properties are going to be on your test, so let's look at an example, a couple more properties. So what property would this be?
Multiplicative identity.
Multiplicative identity. And if you don't like the word multiplicative, you can abbreviate. Mult-ID, multiplicative identity. What about this one? What's that?
Inverse.
That's the multiplicative inverse. So this is your identity, this is your inverse for multiplication. What about this one? That's your additive inverse. Remember, when they cancel each other out, it's always an inverse. When they cancel each other out, it's always an inverse. What about this one?
Associative.
That's associative of addition. It can't be commutative because XYZ, XYZ, they're in the same order. Do you see that? All that's changed is the
Parentheses.
grouping, the parentheses. That's associative of addition. What about this one? What's that? The order changed, so it has to be commutative. Commutative of multiplication. One more. That's associative of multiplication because 3xy, 3xy, no order changed. The only thing that changed was where I put the parentheses. Associative of multiplication. All right? All right, let's go back and look at problem number 8. Since we had a question about that earlier, let's look at problem number 8. So I've given you this formula. All right, here we go. A says, oh, this is a tricky one. Read your problem carefully.
Wait, so did me and Maya get those right?
Yes.
Oh, okay. Okay,
Write the equation for the situation. So we are on problem 8 now. We are reading the question and it's a little bit tricky.
yeah, snapped on my finger.
When you write your equation, you are supposed to plug in a number for this and this, okay? So in the problem, they give you the information to plug in. So, what does the problem say about the initial velocity? It is 100. What does the problem say about the initial height?
On the ground.
It's on the ground, which means its height is 0. This ball is not starting at the top of the building. It is starting on the ground. So its initial height is 0. So I'm going to go ahead and rewrite my equation. I do not like to have that plus 0 on the end. It confuses me. So I'm just going to write my equation like this. Is that okay with everybody? This is the answer to A. This is the equation we're going to use to solve all the rest of the problems. Here we go. Question B. How high is the ball after 1 second? Now I got to do something with that 1 second. I'm either gonna put it in here, or I'm going to put it in here. Where does 1 second go into the equation? For t, it's a time. So h equals negative 16 times 1 squared plus 100 times 1. Let's not use our calculator on this, kids. What is 1 squared? 1 times negative 16. Negative 16. What's 100 times 1? 100. Now, if you want to use your calculator to figure this out, it's okay, but I'm afraid you're going to get confused if you try to do it on that. 1 squared is 1. You don't need a calculator. So the answer is 84 feet. Question was, how high is the ball? The answer is 84 feet. Next question. When does the ball hit the ground?
It's already on the ground.
Well, but it got thrown up into the air. So it looks like this. It's on the ground, it got thrown up into the air, and then it's going to come back to the ground, right? So there's actually 2 times this is on the ground, at the very beginning and then at the very end. Okay, so here's my equation. Once again, when they ask me a question, I have to have a number to plug in either for h or t.
H is 0.
H is 0. It's on the ground. How do you want to solve this? Katie, you okay over there? Okay. How do you want to solve this? I would factor it, Tim. I'm with you on that. There's only 2 terms here, kids. So I would just look at that and I would say, what can I take out of 16 and 100?
2t.
I can certainly take out a t and a
4.
4. So I'm going to pull out a negative 4t. I'm going to go ahead and pull that negative out. And if I pull out a negative 4 and a t, what will I be left with here?
4t minus
4t.
25.
Minus 25. Very, very good. Now what do I do with those 2 things now that I have it factored? Now if I distribute, it's going to take me right back to this. So that would be a check.
Take it back to the middle.
Now I'm going to set them equal to
0.
0. So negative 4t equals 0. And 4t minus 25 equals 0. What do I do here to solve this? Divide by 4, negative 4. And what happens when I divide by negative 4?
You get a positive 1. No, negative 4 divided by, oh. I was tripping.
I'm talking about over here. I get 0, right? Kieran, that's your point. 0. That's where it starts.
Oh, okay.
Now this is going to be where it lands.
Yeah.
So when does it land? 25 fourths seconds. Now, I can sense some confusion. Oops, not that one. I can sense some confusion with this equation. How do I solve that? Now, to me, because I'm old, I do this for a living, it makes perfectly good sense to me to factor this. That's what I'm going to do. That's the easiest, quickest way. But if that didn't occur to you, notice this is a quadratic equation. So what can you always do with a quadratic equation? If you can't think of anything else, what can you always do?
Quadratic.
Exactly. And if you were using the quadratic formula, A would be negative 16, B would be 100, and C would be 0. That's how your quadratic formula would work. Okay?
The answer is 0 and 25.
25 fourths.
25 fourths, yeah.
Yeah. And And the actual zero, or the actual answer is, the question was, when does the ball hit the ground? That would be 25/4 seconds. It starts on the ground at time 0, so that's why we got that answer, because it's on the ground there. This would be the actual answer, 25/4 seconds. Okay? Does anybody see anything else while we're still together in practice test 3 that you think we might want to take a look at?
3C.
3C. Okay, we did a couple of these yesterday, didn't we? How do we approach problems like 3C?
Oh, you gotta split it up.
You gotta split it up. We call it factoring by grouping, but you gotta split it up, works okay too. That's what you gotta do. Gotta split it up. So, do you remember how to do this? Jared, do you remember how to do this? When we say factoring by grouping or split it up, do you remember how that works?
You like x squared and then you factor.
Exactly. So you look at the first two terms and you say, okay, I can take out an x squared. What's left if I pull an x squared out of the first two? Jared, can you answer that? If I take an x squared out? Minus. Yep, perfect. That's it. First term done. Okay? Now, what about these two? Girls, anybody over here at this table? What can I take out of there? Anybody?
9.
A -9. I would pull out the -9. And what would that leave me with if I took a -9 out?
X plus 2.
X, whoa. Minus 2. If I pull out a negative, that's going to leave me with a minus there, which is a very good thing, because what has to happen, gang? These got to match. If they don't match, you are wrong, or you're stuck, one or the other. So I'm going to write down the one that matches. Ethan Topham, you remembering this from yesterday?
Yeah.
So I write down the one that matches. Then and I don't square it or anything, I just write it down. Then I take the other two things and put them together in a parentheses. Okay? Now, what about this?
X